Hello everyone, welcome back. So today I am going to talk about a hello world send and receive message using RabbitMQ, and it will be built with ASP.NET 5 console application. Now the course outline is we'll cover these. Now let me tell you before I embark on the journey for this tutorial is that it is based on a code snippet that is in the hello world tutorial in the RabbitMQ site, official site, but I have extended this code to the way that we are going to do it here. So the original um, URL, your original tutorial is in the description below in the YouTube video. And today we are going to introduce to the message broker with RabbitMQ and create a RabbitMQ environment running on Docker container and create a publisher console app that creates and sends a message and adds it to a queue and create a subscriber console app that receives the message from the queue and consumes it. So let's switch over to the next slide. So in this tutorial, as I have written, I have used configuration file app settings.json to configure the host parameters rather than hard coding them, which is used to create the connection. Now, since this is an app console application in ASP.NET 5, and the console application, some of you must be aware that it doesn't have out of the box configuration and dependency injection. So I will do all that before embarking on to the actual code for the publisher subscriber um, model. So RabbitMQ Docker container uses custom username and password and not the default guest ones created automatically. So the Docker container that I have created on the Docker desktop for Windows is not using the guest ones, which is automatically created, but I will show you what command I have given to create the uh, username and password, and you can change it in your instances. And of course, you'll have to have the Docker desktop for Windows installed and running in order to run the project. So if you are not familiar with Docker desktop for Windows, I will leave a link below in the description of the YouTube video. So let's see what is message broking jargon. So a producer means a sender, or producing means sending. It is a program that sends messages in a producer. So you can call this as a P, and a queue is the name for a post box that lives inside RabbitMQ, and it is essentially a large message buffer that stores messages. And you can say this is a compartment, is a chamber. There are lots of messages within a queue, and this is the queue name, whatever queue name that you choose. And finally, the consuming means receiving, or a receiver is also a consumer, which is nothing but a program that receives messages, which is a consumer. And it mostly waits to receive the messages, and it can be denoted by a C within any shape. So putting this all together, we have got this producer, which is actually producing the message, which is generating the message. You can call this publisher also, and it is putting in a queue with a particular name, and this is the part which the RabbitMQ plays. It's a message broker as well, and the consumer consumes these messages. Okay, so another important thing to note is that the producer, consumer, and message broker don't live on the same host. Indeed, in most applications they don't. They can all live in the different hosts. Like what we are creating today is a Docker container which holds the message broker, and the producer and consumer are living on my local host. An application can both be a producer and a consumer too. This is a special case which we are not going to see in this current tutorial. And the Docker container used for RabbitMQ for creating the RabbitMQ environment in this tutorial was created by issuing the following command from the Windows PowerShell. So docker run, this is a Docker command. This is running to create, and DTIT, I will not actually focus on what do they mean. So you could just read some Docker documentation, and this is the host name, and I'm giving a host name as my RabbitMQ and give it a name RabbitMQ3 server. Okay, so if you get rid of this name parameter, name switch, then it will take a arbitrary ID, which will be difficult to, which is not the way to go. So it will be known by this RabbitMQ3 server, and this is the message broker port that it lives on, and then this is the administrative dashboard for this RabbitMQ, and this is the message broker um, I mean port that it is using 5672, and 15672 is the admin dashboard port. And then the RabbitMQ default user is user. You can change it to any name you like, and if you get rid of the default user, it will take automatically the guest as the user, and then guest as password, but here you are changing to user and password, so I'll be sticking with this, and this will be shown as RabbitMQ3 management. So I leave this part for you to explore in some other documents. In the Docker documentation, you will get the message, I mean, meaning of these switches clear from there. So I have actually earlier created two containers for the RabbitMQ. One of this is RabbitMQ3 management that we have already shown you the command for, and this is now running. This is running on port 15672. Now remember that this was created with the custom user and password, and this was created with the guest default username and password, and this was also experimented earlier, but I will stick to this, and this is the running one. So this is, you can stop it and you can rerun it, you can just delete it, you can uh, put a CLI command for this. So this was created, this Docker um, container was created by using the Windows PowerShell. Right. At this point, let us see the RabbitMQ admin dashboard. And as you remember, I have used these two credentials for the username, user, and password while creating the Docker container, and I'm able to log in with this. Now I have quickly run this send program or publishing program, and it is sent hello world program from RabbitMQ site. Okay, so this is publishing this message. Now let's see this message on the RabbitMQ dashboard, which will be a good idea to see now. So here you can see that get messages, there is one message, and the queue is routing key is hello, and you have got this message. Okay, so hello world program from RabbitMQ site. So you can see this is a payload. So you can see everything that is happening on the RabbitMQ dashboard, admin dashboard. So now if you click on the other project, receive. So click on receive. Let's see how it changes the things. So I've got this waiting for the message and received hello world program from RabbitMQ site. That is received the message published by the send program or the publisher. And then let us see what else we can see. Getting back to RabbitMQ, with both these programs running, and the receiving program having received that hello world program from RabbitMQ site. So you can see that the connections tab, if you click, this is just one connection, username is user, running, connection is in running state, and channels, there is one channel, the username is user, and the channel state is idle, and exchange is actually a more complicated topic which will be covered in some other forthcoming tutorial. And queues, so this queue is also hello, which we'll see when we analyze the program. We have created one channel, we have created queue in the code, and the state of the queue is also idle. And then if you see the messages, you can again see the messages from the queues tab. This is get messages. So get messages, if you click on get message, queue is empty because it is not getting, it has got one message, and that's all. And you can delete the queue, you can purge the messages, and whatnot. So let's switch over to Visual Studio again, learn the coding. So now let's get over to Visual Studio where I have created already two projects. So one is the send project. So just to save time, I've already put it in place. Now here, first of all, what I wanted to show you that you are creating a factory of the connection factory type. This is a connection factory instance. So here I have put this host name, username, password, port, etc. These are the parameters, or these are the you can say the properties of this connection factory. As you can see, connection factory dot host name, connection factory dot username, and the thing that I have differed from the original documentation is that the I've got it from this piece of code which I've initialized over here, which actually allows me to create a app settings.json file. And I have created the app settings file, which is not a part of the default template for console application. So this is the JSON file with app config at the top node, and within that there's a SMTP options, host port, username and password. And this one I'm just initializing an instance of iConfiguration Builder interface. So it is a new configuration builder, and then this way you can add any JSON file, and then this iConfiguration type interface initiation will be done by using the build method of this configuration builder object, and it will actually create, you'll be able to use it, the iConfiguration object you'll be used to fetch whatever is there, fetch these sections from the app settings. Now, this part is automatically done for you in ASP.NET Core web application, but not for this console application. So you have to basically, this is a configuration of the API for the console application. So host name, you can get it from this by using this configuration object dot get section method. Get section is gets the configuration subsection. Then again, get section, this is a chaining of subsections, because within app config you have got SMTP option, and then within SMTP option you've got host. Okay, so again, looking into the app settings.json, you've got app config, then SMTP option, and these are all subsection. This is a subsection of app config, and host, port, username and password are subsection of SMTP options. So here, then using this um, connection factory object factory, you are creating a connection, and then this connection, this connection, this abstracts the socket connection and takes care of the protocol version negotiation and authentication and so on for us. So here we connect to a RabbitMQ node on the local machine, hence the local host. So basically this is the local host, but a particular port is used by the message broker, which is 5672, and it is always the same. Okay, and if we wanted to connect to a node on a different machine, we'd simply specify its host name or IP address here. Next, we create a channel. Okay, now this is what we are creating, a channel, which is where most of the API for getting things done resides. And to send, we must declare a queue. So here is we are declaring a queue, channel.queue declare. So it enables us to send our message to a particular queue, and then we can publish a message to this queue. First, you have to declare a queue, create a queue, declare a queue, and then you have to send the message to the queue, or publish a message to the queue. So basically here this is our message publisher, our sender, and our message consumer is receive.cs, which we are going to talk in a second. This is the receive application which we are going to talk. So let's go back to send and complete our explanation. Now we have come till this part. Now this queue declaration is idempotent. That means queue will only be created if it doesn't exist already. The message content is a byte array, so this is a byte array. So you are creating a message, you are initializing a string, which is now converted into a byte. You can see byte array, it is the body. So encoding.utf.getBytes is actually converting this string, converting the message into a byte array. And finally, we are calling the basic publish method for the channel and passing these values: exchange, routing key, hello, basic properties null, body body. And then on the console, we are writing uh, this sent, whatever be the message. Okay, sent hello world program from RabbitMQ site, and then press enter to exit. Now, before moving on to the uh, receive, the consumer explanation of the consumer, I would like to show you that I have actually had to install some NuGet packages. So which are these? So please make a note: Microsoft.extensions.configuration and Microsoft.extensions.configuration.json and RabbitMQ client. Now these two NuGet packages, they are installed because I wanted to configure the application to use the app settings.json parameters. But if I had used hostname as whatever it brings, and then the username as user, password as password, basically if I had chosen to hard code these parameters, then I didn't need to bring all these NuGet packages, which is important to remember. And the same NuGet packages have also been installed from the receive application. So as for the, now I am into the receive message. So this is the consumer, and if you look into the NuGet packages, you'll find the same NuGet packages over here. So installed are Microsoft.extensions.configuration, Microsoft.extensions.configuration.json, and RabbitMQ.client. So coming back to receive, now one more thing I needed to point out, that here the program file is almost redundant. You can say that program file is not needed, and I have commented it out, and it was the same case with the sending program, the message publisher. Okay, so why? Because I have chosen to stick to the basic coding given in that tutorial in the RabbitMQ site. And um, the thing is that they have used a static void main as the entry point for this receive class, and similarly it was for the send class, static void main, because you can't have two entry points for the same program. So I have actually blocked this program.cs, is commented out, because this is not playing any part. This is as if it is non-existent. You can remove it also, it will still work. Okay, so this part of the uh, application for the consumer side, or the subscriber, you can call this a subscriber to the published messages, or receiver, subscriber, or consumer. So this is very much the same. So if you wish to have a look again, so this part was exactly the same till the creating the connection factory. And then what it differs is it is still creating the connection and still creating the channel, and it is still declaring that queue. Now, why this queue is declared again on the receive side, although it was declared once, is because if you start the receive program first, it should not be without a queue, because it should still wait for the message if the send program is started later. All right, and then it is waiting for the message. And here, this receive program, it is unlike the publisher, which publishes a single message. Now we'll keep the consumer running continuously to listen for the messages and print them out. Okay, it will listen for the messages continuously, and then consume it when it has arrived, when a new message is generated. Now a new thing here is this eventing basic consumer. So a consumer is created with this event basic consumer, which is a constructor that sets the model property to the given value, but that doesn't say anything. But you're passing this channel object. Now, what this eventing basic consumer does is that it will push the messages asynchronously. So this is a callback. It is a callback, and that is what this event basic consumer dot received does. It This is the event handler. It is actually subscribing to the event, that is subscribing to the message that is published by the publisher. Okay, it is continuously listening for the arrival of messages from the broker, from the message queue. And it is you are passing the model as an object, and this is the event args. So body will be a variable which will be event args dot body dot to array, and the message will be encoding. This is again it is now it's a byte array. It receives the byte array because publisher creates a byte array, and this receives the byte array, and then it reconverts the byte array back to the string. You can see encoding dot utf dot get string. It is getting a string, and then it is writing on the console the message. Now let's see. To test this, we need to run these two programs separately. That's why I have created two different solutions for showing this hello world application. So there's no harm trying running this receive first. It will receive for the queue. So this program is now running. So waiting for the messages. Now let's run this send. Now sent, you can see sent hello world program from RabbitMQ site. The publisher has sent this message, hello world program from RabbitMQ site, which is this message, hello world program from RabbitMQ site. So sent this, okay, with X appended. Now if you look into this receive again, uh, so waiting for messages received. Initially it was waiting for the messages, and because it was started first, this queue was started first on the receive side, and now it has received the hello world program from RabbitMQ side. So it has sent the message from RabbitMQ side, and this has received the message from the RabbitMQ side. So that's all for today. So in this tutorial, we have learned what is a producer and consumer, or publish and subscriber model for message broking, and what is a message broker, and how you can create a simple hello world application using RabbitMQ, where the RabbitMQ environment is created in a Docker container. It is running out of the Docker container. So thank you for watching. And if you have liked my video, please subscribe to my channel, share it with your friends, and put your valuable comments.